Hello and welcome. Today I'm here with Julia Liu, a distinguished data scientist here at Intuit, and we're going to be talking a little bit about the 101 level of ML and AI. Julia is going to be giving a really fun talk over at Women in Data Science, the conference. And before that, as we're recording right now, we're going to pick her brain a little bit and learn some of these basic level concepts, but in the context of applied AI and ML in like the industry and how we can solve customer problems, which is of course what we're always focused on every day here at Intuit. So without further ado, hello Julia, welcome.
Hi Lucy.
How are you doing today?
Good. Excited to be here.
It's our first time doing this kind of a video format, so let us know in the comments if it's a fun one for you all. But we're going to dive straight into the questions. So we do have some notes over here. Tell me a little bit about yourself first. Let's do an introduction. Your role at Intuit, how long you've been here, what's your job like?
Okay, so I'm a data scientist at Intuit. I joined Intuit 4.5 years ago. I joined on October 1st, 2018. So it has been a fun 4.5 years so far. My job is basically developing AI solutions for QuickBooks, Intuit's QuickBooks product, basically helping small business in understanding their business, getting customers, doing their accounting.
So you've been with QuickBooks this whole time that you've been here?
Yes, 4.5 years. Yeah.
That's the sweet spot, the happy place. Awesome. What about your title? It's a big one. It's Distinguished Data Scientist. What does that mean exactly?
Well, first let me say, being called distinguished doesn't make me any more distinguished than what I really am.
You don't feel distinguished?
So it's basically just merely a label, but it does convey a sense of seniority. So like a little bit on the old side. So therefore, basically, as data scientist, I build AI technology, and as a distinguished data scientist, building AI technology is not the only goal. It also means that I need to help my team grow. So give them space to shine, nurture their growth, empower them to do what they need to do, and also provide the necessary support and guidance to my team members.
Very much a role of like guidance and mentorship and leadership. That's what the distinguished title conveys? Or
That's it. Yeah.
That's interesting.
Yeah.
How did you end up in this role? It's not common that we see distinguished level engineers or data scientists here, so.
It's like natural progression. So I had always been in the field of data science. So I had been tackling the statistical modeling problem all the way back from my PhD days. So it's like my PhD is 2001, so it's basically like 20-something years of experience.
Wow.
So basically in this field, I tackled many different problems, varying from troubleshooting machines to build directly customer-oriented problems. So over time, we discover commonalities of problems as well as individual specificity of each problem. So then like a few learnings and get to where like this level is. I enjoy building technology and I enjoy helping people grow. So that's how I
naturally grew into this role, just over time with building expertise and mentorship.
Yeah.
That makes a lot of sense. That's awesome. Cool. So let's move a little bit into the meat of things, right? So you'll be giving a talk at the Women in Data Science Tel Aviv conference. Can you tell me a little bit about Intuit and our role in the Women in Data Science organization, why we're participating in the conference, and how your talk fits into all of that?
Sure. So Women in Data Science, it's a conference, or you can consider it as a community gathering. The goal is basically educating and inspiring data scientists at all levels and encourage women in tech. So Intuit has been a proud sponsor, and our employees has been ambassador for quite some time because we view this as a good cause, and it's well aligned with Intuit's charter of women in tech, supporting women in tech. So inclusion and diversity has always been our goal, and we have been constantly making progress towards that goal. So I can give a solid data point. In general, women in tech, in the whole tech industry, we are underrepresented. In fiscal year 22, Intuit has achieved 33% of women in tech. So that means every 3 engineer, one of them is a woman. So that compared to industry benchmark, we are doing very good. And then we are committed to make that number goes to 38% by fiscal year 25, which is 2 years from now. So that's like the general overarching like Intuit mission. And then in terms of women in data science, we have been the ambassador for Tel Aviv, and also we participated in the Stanford Women in Data Conference as well, and we are thinking of opening one in Bangalore pretty quickly. Yeah. So and actually this is going to be my first trip to Tel Aviv, so I'm excited.
That is exciting. Anything you're particularly looking forward to in Tel Aviv?
Meeting the community at the Women in Data Science conference. Also meeting my colleagues. So I would be making a site visit to the Intuit's
our Israel office.
Israel office. And I had been working with many colleagues. We had been meeting each other on Zoom, and now it's like my chance of finally getting to meet them. And then like being in Israel
a different place.
Culturally, that's pretty exciting too.
For sure.
So I'm looking forward to it.
Yeah.
And then coming to my talk at the Women in Data Science conference, it's basically I'll be sharing my journey of accounting automation with my audience. So basically how we have leveraged machine learning and AI technology to automate the process of accounting. And by the way, accounting is not a sexy topic. It's it's considered one of the boring jobs, and people need to spend a lot of time in it. It's very error prone. People may not have the necessary accounting knowledge. Not everyone go through accounting education.
Very nitty-gritty kind of subject.
If we could leverage the technology to take that off people's plate, that would be wonderful.
So we will be digging in our conversation today a little bit more into the details of your accounting automation implementation, basically. So taking apart the tool set that you've leveraged through this ML AI data sphere, the bits and pieces that you use to create this solution. We're going to be using this as a almost like a syllabus of like all of these different topics in ML and AI that you can explore. And we'll start at a 101 level at the talk today, just enough to get you all started. The goal is to get a primer, and then you can dive deeper if you find any topics that you do find more interesting beyond that. So there were a lot of I have a bunch of notes here. We're both holding a lot of notes. There are a lot of headers under this big umbrella. So in our accounting automation product solution, basically, the multi-tool of ML and AI really came in handy. And it's gonna sound like word salad, but we'll break down each of these concepts one by one, okay? So topics covered in your talk include NLP, natural language processing, and information retrieval, recommendation systems, transfer learning, confidence scores, clustering, classification, and anomaly detection, just to name a few. This is not even an exhaustive list. Before we really dive into the how, let's first talk about the why of like why accounting automation was an important, why was accounting something that needed to be automated? And why was this a good problem space for an ML and AI solution?
Yeah. First, I want to give a bit of customer empathy. So you and I both work in corporate structure, right? So we live, 9 to 5, 9 to 6, whatever life. And many of us have an idealized image of small business life. So it will give us more flexibility, more autonomy, more fulfillment, creativity. So all of these sounds very nice and cool, right? And maybe even dream about financial freedom. But in reality, the life that a small business owner faces is much more challenging than that. I mean, all of the above it is true. However, there are challenges associated with them. So getting customers. Okay. They as business owners, they need to get customers. They need to manage the cash flow, make sure that they are not underwater. That's a constant stress. Get their tax done. That's another major source of stress. So therefore, it's whatever that we can automate to help them to take the burden off their shoulders so that they can focus on delivering the product, delivering the service that they intend to deliver, help them achieve the goals that originally inspired them to. That's basically the goal of automation. Nobody said that I want to open a photographer studio because I get the chance to do accounting, right? That's just not the way how it works. So therefore, it's really we need to help them to perform all the tasks in a efficient and effective manner. So we in my work, we pick on accounting automation in particular. That's because accounting is such a time-consuming job. So we are talking about transactions being the atoms of business activities. The moment that you connect with your bank, I don't know, 3,000 transactions would flood in, and then we need to make sure that they are all recorded properly, because without them recorded properly, you don't get any business insights. All the bets are off. So that's why we need to have the accounting automation.
And this automation aspect, is it only like the classification of transactions, or do you go beyond that even?
We started from transaction categorization, but then we go way beyond, because there are many things. Accounting is basically, if you look at the essence of it, it's sorting transactions into accounts, right? So you have how many transactions, 3,000 transactions, and then you have 100 accounts. You need to make sure that everything is recorded properly. But there are many things that can be automated. So transaction categorization is obviously one part of it. However, the setup of the accounts is also crucial. So if your account was set up in a messy way, then there's no proper ways of sorting a transaction into the account, because the account by itself is not set up properly. So we need to make sure that the account, which we call as, in accounting term, is called chart of account. So we need to make sure that the chart of account is set up properly, and we make sure that QuickBooks guide our users in that setup. And once the account is set up, then the transactions categorization, that is the second stage of accounting automation. And then every month, the business owner, they need to attend to their books. They need to review the books, make sure that everything is done properly, right? And then they may get monthly reports. So the reviewing job is, again, a lengthy process, because just going through the transactions one by one, that takes time. And then people's mental workload is hard. You are jumping all over the place, right? So certain transactions deserve your attention. Certain transactions, they don't deserve your attention, right? So not all transactions are created equal. And knowing what can safely be automated out and what really the customer need to focus, that is a crucial problem. So
that's a big problem.
Yeah, it is. So the target state, I'm not saying that we have achieved the target state, but the target state is more money, no work, and higher confidence. So if we can, help our customers to get more money without basically try to minimize the amount of work that they need to do, and then be more confident in the things that they do. That's the goal.
I love that. More money, no work, higher confidence. I've definitely heard it said around a lot in the Intuit sphere. It's fun to see it in application today. So let's start going through the lexicon, shall we? With some big words.
Sure.
I did take an intro ML class in college, but even I'm a little rusty on these, so it'll be helpful for me. Let's start with classification.
So classification is one of the most basic machine learning techniques. That means that you have data points and then they fall into different classes. So the typical example that you hear in classroom is that you have an image. Is that a dog or is it a cat, right? So coming to accounting space, you have certain transactions. You say, well, is this transaction a business transaction or is it more look like a personal transaction? If it's a business transaction, then you say, well, does this look like an expense or does that look like an asset? Expense and asset are treated quite differently in accounting terms, because in IRS mandates that expense can be written off while asset need to be depreciated.
Yeah.
So if things got messed up, there would be consequences. The text would be messed up.
And classification is a very common problem in the AI space, right?
It's the foundation stone. Yeah.
Interesting. Okay.
Yeah.
So in this case, it was a very obvious application, I suppose. When the moment we were faced with the classification problem, the instinct of, oh, we can use ML to solve this it's kind of an obvious fit.
Yeah. Majority of the machine learning problem boil down to the end into either supervised learning or unsupervised learning. So classification is supervised learning. It is called supervised learning because it comes with the supervision signal.
Like
1 or
tagged
0,
data
dog or cat.
I see.
Yeah.
Okay.
Yeah.
Gotcha. How does clustering, that's our next word, clustering, how does that fit into the puzzle?
Well, clustering is an unsupervised learning method. So that means I don't have the supervision signal. I don't know whether it is class 1 or class 0. So, however, the data does exhibit certain patterns. Similar transactions or similar data points, they exhibit similarity. And then dissimilar ones, they are far apart. So being able to explore that structure, being able to identify which data points are similar, that can help us do a lot of things.
Anomaly detection is our next one. How would you define that and how does that fit into everything?
Yeah, anomaly detection basically means that you have norm and you have departure from norm. So typically data points would exhibit common patterns, but once in a while you have outliers which lives far away from the rest of the data points. So those are called outliers. Outliers could be certain one-off phenomena or it could be mistakes. So we leverage anomaly detection to pick up these data points and then bring it to the attention of the user and say, okay, that sounds like a little strange to me. Do you think it's an error or it's true?
Is this a case where clustering is helpful, where you use clustering to identify patterns? Like,
They could go together. But then, in terms of techniques, anomaly detection and clustering, they are overlap set of techniques.
Overlap techniques. Yeah. And just to go back again to the classification problem, is anomaly detection a classification problem? Can it be treated as such or no?
Anomaly detection normally is considered as unsupervised learning.
Unsupervised learning.
So we don't
because it's like pattern recognition. More
yeah,
so
but then I mean, once in a while you will also see techniques that try to leverage different types of techniques.
Interesting. Yeah. Okay. This is the confusion, I think, of the ML and AI field, is that there are so many. It's a word salad, right? All of these words that we're saying, so many of them overlap with each other, but each of them is their own unique technique, but also you can, they overlap and interact in interesting ways.
Well, it's much like mathematics, right? So
mathematics, I like that,
they have different field, and, people find interbreed of ideas, and typically that's when, breakthroughs comes about. Right?
Okay. Yeah. Let's keep going. We have 3 more here. We're making good time. This is a great 101 level for Dummies Primer. Next up, we have natural language processing, also known as NLP, the common acronym.
NLP is a subfield of machine learning. Basically, it focuses on human language. So human language is obviously a very important aspect of our life, and coming to business world, a lot of the activities are recorded in natural language, and then people need to converse, understand those in terms that make sense to them. So NLP is a collection of techniques which enable computer to understand, to interpret, and sometimes to even generate response in human language. So in our case, you can imagine that I've told you about transactions and accounts and matching transactions with accounts, and all of these come in human understandable terms. So a transaction is basically what you normally see in your bank statement. On certain days you pay $300 to Home Depot, for instance, right? So that's natural language. You would be able to understand what is happening on your bank statement.
Right.
Similarly, on the account side, on accounting side, nobody calls their account, account 178, because it's not intuitive. They would rather call it supply and material, for instance. So natural language would help us to understand what what these entities are, and then make suitable recommendations.
So essentially building a model that can handle the fact that most of our data is targeted towards, is using natural language. Exactly.
Correct.
Love that. Okay.
Yeah.
Last two. Penultimate one, we have confidence score is our next one.
Yeah, confidence score is actually a byproduct. Typically, it is a byproduct of, for instance, classification can come with confidence score. So you say, okay, I have an image. Is that a cat? Is that a dog? And then the confidence score will say, oh, I'm 80% confident that it is a cat. So if that confidence score is calibrated properly, that means out of 100 images that you declare as cat, 80% of them should actually be cats. So confidence score reflects how confident the algorithm is regarding its prediction. So how do we use that? Basically, it will tell us like not only like what we predict this thing to be, but leveraging our confidence so that we can do this for automation. You know, as I told you, certain transactions we are very confident. Like McDonald's, you go there only for food, right? And USPS, you only go there for shipping. On the other hand, sometimes the confidence is very low. For instance, if Julia sends Lucy a check of $50, you really don't know what that $50 is about. It could potentially be anything, right? It could be that I invested $50 in your company. It could be that I purchased $50 of goods from you, or maybe service, or I'm paying you back because I owe you something, right? So all of these are possibilities. So confidence score gives the leverage, so that say, okay, with for the data points that I'm confident about, I can automate. On the other hand, for the things that I'm low confident about, oftentimes low confidence is a result of low signals. Like the check case, you really don't have any signal, and the best thing that you could do is to say, well, I know that I have very low confidence and I need to extract the information from the user.
Got it. Is this something that will we ever surface confidence scores to the end user? Do they ever have a sense of the fact that we have been calculating a confidence score for each of these transactions and that we're surfacing them, the lower confidence ones? Is this something we indicate in the product to them, or does it just show up as like a review queue, basically?
We actually, right now, accounting automation is still work in progress. So we have been launching different kind of tests, user-oriented tests. So we kind of tell them that, we tell them that well, we are automating some transactions away, and then certain things we need your attention, and then engage them in a guided question and answer flow.
Got it. So to collect a constant sort of stream of user feedback as we continue to refine how we calculate our confidence scores even.
Correct.
Interesting.
Yeah.
Would that be considered like another term I've heard in the ML sphere is like human in the loop machine learning? Is this an example of that?
I would call it an example of it.
Okay.
It's basically, it's not only harvesting the prediction itself, like the machine learning output, but also knowing when you are right, when you are likely to be wrong. So that's extremely important.
Gotcha.
Yeah.
Okay. So last but definitely not least, because there's a lot more in the ML and AI data space, but the last on our list today for the 101 level is the phrase transfer learning. What is transfer learning? What does that mean?
Transfer learning refers to the technique where you start with a pre-trained model. Typically, the pre-trained model is trained based on very large scale data set. And then you use that as a starting point. You start adapting it, fine-tuning it with respect to smaller data sets. And then I know that you are wondering, like, why do we need to take this two-stage process? So let me give you an example. So in our transaction categorization, if you are a new user, then there's nothing much that we can do to personalize for you because we don't know your preference. So we go with the large-scale model. We learn from everybody's transaction, and then we make suggestions how you would like to have them categorized. However, each business is different. So some business are happy with like the coarse grain
default
account
kind of
setup, and some companies, they are very particular, and then they are more detail oriented. So for instance, some company may say, okay, any transactions related to vehicle, I put them in an account called car and truck. That's fine. But other companies may say, let me tease out, fuel as one account, car maintenance as another, and then car insurance as a third. So this way they get much finer grain reporting. So all of these needs need to be satisfied. So we achieve personalization through transfer learning. So we train first this large-scale model as the starting point, and then we adapt it. We fine-tune it with respect to every user's personal data, given that that user have sufficient data. So this operates much better than the original model. So right now we have 2 million models in that scale, which means that for every QuickBooks customer with sufficient data, we have a personal model for this customer. So this is what we are doing with transfer learning.
How do you determine if a company has sufficient data, and then how does the switchover happen? Do they opt in, or do you just kind of kick it in for them automatically?
Right now we are just doing based on volume. So if a user has sufficient number of transactions, let's say over 500 transactions, that's when we start to build the personal model for this user.
Okay. And is that a threshold that you adjust as time goes on, or is there like an optimal point for the threshold in terms of enough data?
Of course, there could be many fine-tuning ways here, but we feel like even like a volume-based switching rate in practice it's working pretty well.
And it's automatic right now.
Yeah.
Okay.
So 2 million models operate refreshed potentially on a daily basis. So that's all on the automatic automation, because we really don't want to do it.
Yeah, of course. This is the boring stuff.
Yeah.
500, as much as that feels like actually a small number to me, 500 transactions to categorize
you would have it
manually,
that
would be painful.
Yeah.
For sure. Okay, let's actually zoom out a little bit in scope. So we've covered a bunch of like 101 level terminology, right? But let's back up a little bit and look at the problem space of ML and AI. So I know the phrase that we keep talking about is like hammer looking for a nail. And so how do you determine actually whether something is the appropriate nail for the ML hammer? Like, how do you find the right problem space? The obvious ones we talked about are classification, anomaly detection. Other than those two sort of maybe more obvious definitions, how do you otherwise identify a problem space for AI?
Public may perceive that AI ML as a hammer looking for a nail, but in reality, it is often not. So, and even like the practitioners who are new to the field, they may feel that way. But really, it's about understanding the problem and then understanding which solution fits the best. So that requires a lot of collaboration with the business teams because they understand the business need better than we do. So and then we'll figure out first we'll understand thoroughly what is the problem, and then we figure out what is the solution for it. The solution may be an AI solution of all these different techniques in the word salad, or sometimes it may even not be an AI solution. That's fine. That's totally okay.
Have you had an accounting problem that you all thought about tackling with AI and then decided against?
There are plenty.
Can you give me one example maybe to illustrate?
Basically, anything related to understanding and uncertainty, AI has an edge in it. On the other hand, if something is very deterministic, it can still be very complex. Engineering solution could be a good fit. So, for instance, tax is very complicated. Tax is very complicated. However, tax is very deterministic.
Yes.
Yeah.
Can you elaborate on what deterministic means in the tax space? What makes it deterministic?
If you are married, then the next question is: are you filing jointly or are you filing separately? So the tax tree actually go into many.
It's a tree, right?
Many space. So Intuit's TurboTax is actually a knowledge engine. It's not an AI.
Knowledge. I guess we call it knowledge graph here also.
Yeah.
It is a graph. Yeah. That's true. I love that. Great example. We got a distinguished scientist here to talk us through a 101 level list of definitions, which I think is we really got spoiled today. But I also want to talk a little about, as an expert in this field, someone who spent a lot of time in it, building your knowledge, how do you keep up with such a fast-moving field? And based on your personal experience of keeping up with things, what's your advice for people looking to get into the ML space and how they should keep up with things or start learning?
Yeah, so basically, you never get bored in this field because your arsenal is continuously like growing, right? So
Right.
that's the exciting part about this part of the tech industry. So number one advice is keep on learning, keep up with the trend, get ahead of the curve, be the disruptor rather than the disrupted. So I think that's the exciting part. But at the same time, we need to not get lost in this huge arsenal of techniques. So always focus on the problem, fall in love with the problem, not the solution, and also focus on the fundamentals. So any model is only as valid as its assumptions, because every model makes simplifying assumptions to make it manageable. So instead of like pulling all of these techniques out of your collection of tools and try blatantly, think about the underlying assumptions, and that will help our practice to be more efficient.
This is a space where just throwing spaghetti at the wall and seeing what sticks might not be the best approach, actually.
Well, you need to figure out what's the underlying assumption behind the spaghetti.
Right. Why am I throwing the spaghetti at this wall?
Yeah.
Got it. That's wonderful. I think that's a wonderful concluding point also, a little note of learning. I like that it actually mirrors like training machine learning models in general, the iterative process and the keep learning aspect of that is very, very, very present. So thank you so much, Julia, for your time today. Thank you for spoiling us with a 101 level discussion from an expert. And I hope you have a wonderful time in Tel Aviv.
I'm sure. Thank you.
Thank you.
Yeah.